What's up guys, this is Massey. Welcome to another video. In this video I want to show you another optimization question, and it says a soup can of volume 500 cubic centimeter is to be constructed. The material for the top costs 0.4 cents per centimeter squared, while the material for the bottom and sides costs 0.2 cents per centimeter squared. Find the dimensions that will minimize the cost of producing the can. So the volume is going to be pi r squared times h, which is going to be equal to 500. So h will be 500 over pi r squared. The cost is going to be, for the top one, which is pi r squared, it's going to be 0.4. Plus the sides is going to be 2 pi r h, plus the bottom, which is pi r squared times 0.2. Now we need to find out derivative of cost with respect to r. Before that, I'm gonna get rid of h. Instead of h, I can put 500 over pi r squared. So it's going to be 0.4 times pi times r squared plus 0.4 pi r times 500 over pi r squared plus 0.2 pi r squared. That's the cost. Now let's simplify it. It's 0.4 pi r squared plus 200. Pi and pi cancel out, r and one of them cancel out, over r plus 0.2 pi r squared, which with this 0.4 is going to be 0.6 pi r squared. Derivative with respect to r is going to be 2 times 0.6, which is 1.2 pi r, minus 200 over r squared has to be equal to 0. So 1.2 pi r equals to 200 over r squared. So 200 times 1.2 pi r times r squared. So we have 200, 1.2 pi r cubed. So r cubed will be 200 over 1.2 pi . 53.07. So r will be cube root of 53.07. 3.56 centimeter is the radius. H will be 500 over 3.14 over r, which is 3.76 to the power of 2. We have 500 divided by 3.14 divided by 3.76 divided by 3.46. It's going to be 11.26 centimeter. That's going to be height as well, and we have minimized cost. I hope you enjoyed this video. Please leave me a comment if you have any question, and I get back to you as soon as possible. I will leave some related videos in description. Thank you for watching and have a great day.